All right, we're going to move on to the next one. One of my favorites on this list, and RAMBO attacks. And Rudy, immediately when I saw your text message, I was thinking, oh, I think I have an RTL sitting in a drawer. And I went and found this. And
Oh,
what I'm holding up to the camera is a slinky antenna. It's two slinkies. Whoop, two slinkies. And you use this to strap this up onto the wall, and you plug it into your RTL SDR little receiver. I got a little receiver right here. Um, I'm into ham radio stuff. I'm into radio stuff. But let's talk about RAMBO attacks. Give us the high level on a RAMBO attack.
yeah, the RAMBO attack is, well, first, you have to understand that loosely that when a computer thinks, so to speak, it uses its CPU, right? And then it harvests data from its hard drive, even if it's SSD, spinning drive, doesn't matter how fast it is. It's not fast enough to keep up with the CPU as it moves data to the left, to the right, up, down, side to side. It does that in what we call RAM, right? Memory. It's fast, readily accessible, right? So as you move data into RAM, it's just a bunch of electrons on and off, right? That's all ones and zeros, right?
That's
And
right.
there's a pattern. Your CPU know how to read it. It leverages the motherboard in order to move these data sets back and forth. The end result, it builds a little picture for you on the screen, or it prints a document for you because that's what you asked for, right? Whatever the human wanted, that's what it's doing. But all intents and purposes, it's all the data within RAM going left, right, side to side, so that the CPU can make sense for the human, right? So the RAMBO attack understands this, right? One, they understand this, and every time electricity is pumped through RAM, if you will, it creates a sound, right? Different frequency, different hertz, right? But if you can figure out how to listen to it, theoretically, you could hear the ones and zeros, a one and a zero, on or off. We see it every day. Every light switch that has like a little dash and a zero,
Right.
power on button.
Yep.
You'll see like a half circle and then, or almost a completed circle with a line up there.
Yep.
That represents 0 and 1. 1 is when you power it on, that means electrons are flowing through it, and then 0, right, is the O, right? The rest of this
Continuity or no continuity?
exactly, right. So you complete the circuit or don't complete the circuit, and then it happens a couple billion times a second, right? That's where gigahertz comes in, right? A
Right.
million times a second in megahertz. So if
Okay.
you can read that, then you can see what you literally hear what the computer's thinking, right? And you don't need an internet connection because it's through the air, right? Whatever frequency, depending on the frequency, how far away you can hear it, whatever your receiver is. But theoretically, you can listen to the reverberations and equate that to ones and zeros. That is the code. And then if code is code, you use a computer to understand code, right? Or retrieve it, dissect it, translate it back into human readable. Then you
That's
just
right. Okay. So setting the stage here with this particular story, we've got the way that we think computers ought to operate. We think they ought to operate like I'm sitting here looking at a screen and I'm looking at video of Rudy, and we're going back and forth, and I've got this mic and I'm speaking into the mic and I can hear Rudy over my speakers. And this is by design how these things function. Then we take sensitive systems and we say, oh, but this system, this one is sensitive. This
yeah,
one shouldn't be internet connected. We're going to sit this one over here. And you know what? We're not going to plug it into the network. And you know what? We're even going to give the thing its own power source and power supply because we're afraid that somehow power might be used to manipulate the computer. So let's do all of these things to keep this thing isolated. You know what? As a matter of fact, let's even unplug the screen from it. Let's even unplug speakers from it. Let's
they
make it.
remove the Wi-Fi, right? So it can't.
That's right. Let's remove the Wi-Fi. Let's do all of these things. But the problem, as I understand it, is that we're accustomed to the screen being the interface. We're accustomed to the microphone, to the keyboard, to the mouse. But what if you could interface that machine using, it's not necessarily a flaw per se. It's just, you know what? We just never thought about it, that the frequency of the RAM might end up giving us a different kind of picture that we can actually read out of that machine. So is that the understanding?
Yeah, you're right. It's the equivalent of if you go back to your analogy, we interface, we receive information from a computer more times than not via a screen, right? And then, you know, most of the time it's a LED, right? Turns on and off a different
That's right.
hue. You add all the iodes, and then they emit this color, and then you get the picture, right? And then perceive that it's moving, or if it's just a still picture. But what's happening is electrons are going into a little light bulb. Each light bulb has its own hue. When you zoom out, we see the big picture, literally however big your screen is. And then that's how we receive that information. Ah, I'm looking at data right now, right? So it's the same thing, except it replaced light with the equivalent of like hums of a computer thinking of just projecting that picture on a screen. Obviously that hum, you can't just, there's no way to plug in a screen to a hum, right? Yet you have to collect the hum, right? And then use another computer to dissect, hey, what is this hum? Find the patterns, right? And then when you start to reveal, what you just did is you reverse engineered wherever the hum came from. Especially when you know where it did come from, you have a point to kind of tweak your model as you're trying to translate the information. You know what you want to end up with. I want to end up with a picture of Dana. And so you tweak your model until you get it just right. And then you test it with other things you don't know where it came from, right? Maybe it's a picture of a whale, right? Or a picture of Rudy, right? Drinking a beer. And then you use your model that you just created of a known good. I know this hum was from somebody of a computer thinking about projecting a picture of Dana, right? And then you apply it to things you don't know, and then you see if you're right. Then bam, that's called, you know, you just, let's test it. I have a hypothesis, tested it, and then bam, it's working. And then now what you just did is you're retrieving information. It's not necessarily exfiltration, right? Like you're not extracting it, you're just intercepting it. And you said it earlier, where people just didn't think about it. We have these systems you're talking about in your description, where different power source, not connected to the internet. They don't just turn off Wi-Fi. Like they don't even have a card that emits
That's
Wi-Fi.
right.
Just
They
in
don't have
case.
Bluetooth
Yeah, right.
installed. Some of them
Right.
don't even have a mouse and keyboard or USB port on
Yep.
them because they removed all of that because somebody is afraid that somebody could come by and plug something into it.
Right. And so they usually have it, you know, isolated physically as well. Right. But now these researchers found a different way to extract that information when the computer is just on.
Okay. So, does the computer need to be, does malware or something need to be planted on the machine in order to be able to intercept data?
No.
Okay. All right. So now, as we talk about air gap and we talk about, you know, you put a machine, you secure it up, you put it in a secure room, whatever. Receiving information from air gapped computers is not a new idea. This actually goes back, and I had something bugging me when I was reading about these RAMBO attacks, and I was reminded of something, and gosh darn it, I couldn't think of the name of it. And so I was scouring the web. I'm trying to find this because it was old school. It was that you could do this with a CRT screen and reconstruct the images from a CRT. And I'm like, and so I found it. It's called Tempest. And I'll have the link in the notes. But that goes back quite a ways where you could set up a special array of antenna, and you could use the frequency of the it's like cathode ray tube, the CRT, as it's going across and it's scanning your screen. You could reconstruct the images on the other side of a wall. There's also another one that collects the bounce off of a CRT screen from a wall behind maybe somebody who's viewing content, and they could take that and they could sync up a refresh rate to that CRT screen,
I
and
haven't heard of that. Yes.
they could use a photo cell to determine what was, I mean, we're talking about some really complicated math and everything that's involved in this. Also, there is that last one I just said was optical time domain eavesdropping, which that one's super interesting. There's also stealing data from the hard drive LED light. There's also stealing data using the acoustics of a hard drive. Now, that one, I think, from what I remember on that one, it had to be, and I couldn't find an article to support that one, but it was quite a few years ago. I heard about that one where somebody could install a malicious software on a computer, and then they would use either the LED light, the LED. The previous LED one was because the hard drive LED was flashing so fast that it was leaking data if you slowed it down, captured it with a camera
Yeah.
that was fast enough. You could capture the blinks, the ones and zeros.
Yeah.
I was like, this is crazy, crazy stuff to be thinking about. But this other LED hack was that they would use a hard drive access. They would use some software that would exfiltrate data, hard drive access acoustically, and using the light on the hard drive light on the computer to intentionally flash ones and zeros in a very slow manner. It was very laborious to get data this way, but that was another one. You've got the Fansmitter on top of that. That's not enough of air gapping insecurity. There was the Fansmitter, which was another malicious software package you could put on a computer, and you could use the fan speed to exfiltrate data. There's also one of the most famous ones for accessing a air-gapped system and causing chaos, and that was Stuxnet.
Yep. Yeah.
So this is not new that air-gapped computers get compromised. What's new and novel about this one is that somebody took the time to figure out. And if you talked about Israel before, but I think this one also came out of Ben Gurion University, or trying to remember where I got that. But quite a few of the articles that I found relating to this were tied to Israel, to
Yeah.
researchers in Israel.
Yeah. It's really researchers are really there. The whole
Yeah.
industry for the country, that could be like a whole segment by itself. But the infrastructure is like a systemic thing where they identify young talent in different sectors, and then they even have like an army of venture capitalists that feed these ideas and allow people to go research, right? These people, we envy, they had this idea, and I wonder if, right, and then they did it. Also, what's different in Rambo is that they extracting information, right, or just really intercepting it is not new, but they went as far as sending code back. Think about it. If you learn how to dissect something, right, you compile a roadmap on what it's saying, then theoretically you have half of what you need to talk back, right, to insert an input. Because every time you press a key, you move your mouse, you're sending an input through the system, and then however it was emitted, it's doing that same thing. And then whoever dissected that code, reverse engineer, they know that you're moving the mouse, they know that you're pressing the key, right? Yeah. So then they can mimic the same thing, right? If they know when you type in your name or your password, right? Because they dissected the hums that replicate that keystroke, then they can replay it depending on what the receiving end is, right? But so without going into the nerd parts, theoretically, you already have half of what you need if you can intercept in there. And
do we know if anything's been used to inject anything into RAM using wireless technologies? Have you heard of that? I imagine we're not too far away from that.
particular printers, yeah. And then there's certain groups out there that like can't confirm nor deny that it hasn't been explored or if it's been successful. I do know that there's some unclassified papers out there where they did similar things to certain versions of printers,
Hmm.
where they're able to send a printer a job by way of RAM.
Wow. Okay.
So think
Cool.
about like if you have like solid states are the same thing where the only thing that makes solid state different from a spinning hard drive, right? The spinning hard drive just reading on magnetic tape if is there 1 or 0, and then you do a couple billion of these, and it might equal a file, right?
Right.
So a solid state is a little switch, right? Switch that's on or off. How compact, how many little switches depends on how big the drive is, whether it's a terabyte, 4 terabytes, 500 gigs. But you have enough to flip it. RAM works kind of the same way. It keeps this volatile 1 or 0 space. When there's no electricity, it all goes away and they all go to 0.
Or mostly goes away. There's
Yeah.
also been people pulling RAM chips from computers to find out to receive last state of the I don't know how that works,
Yeah.
but to receive the last state of that portion of the RAM.
Yeah.
It's crazy
Yeah,
because you
you're
might
right.
find
Just
passwords and all sorts of stuff.
what really goes away is the there's a little identifier that says, all right, the state of all this lines of 1 and 0s in RAM goes to this job in the CPU. So really, when you shut down power, you lose the little, think about like a old school library. You had like a BitLock, or was it the little drawers you come out, the little index
Oh
cards.
yeah. Uh-huh.
All right, so what you lost is the index card that went back to the CPU, whatever the job was supposed to be. So when you lose power, you still have all the state in RAM, but you don't know what the hell it was supposed to go to. And that makes
Got
sense.
it.
And so, because you don't have a whole file in RAM, you have this whole file chopped up into 1,000 different pieces in RAM, and then how to map it together, you don't know because power went out. But you're right, you have this last state. But if you understand that concept, you put a little electron in there, it flips it to 1, right? And then you zap it again with an electron and it goes back to 0. Zooming out, it's almost like LEDs. Oh, I see a picture of Dana. But if I zoomed all the way into 1 pixel, all I see is like one white space or a
Right.
blue space of your shirt, right? I don't know the whole picture. So if you don't understand that, you send enough energy to RAM, depends on the make, model, what the surface is, how far away, whether you have to go through a wall. Theoretically, right? Just imagine Superman on the other side of something, and he can send a laser beam and then flip these 1s and 0s, these switches on RAM, right? And then he can manipulate data. Obviously, the machine has to be on, right? But you just give it just enough jolt to flip the switch, right? And then you can
It's crazy.
send a file to RAM.
Oh, that's crazy. It's
Yeah.
crazy. It's a different kind of Wi-Fi. It's
Yeah.
like, but AirFi is another name for this. AirFi actually goes back further. And by the way, when we say RAMBO attack, it's actually you would think what we were talking about was RAM random access memory,
Yeah.
but we're not. It's actually radiation of air-gapped memory bus for offense. So it's it's different. So if you're going to look this up and you think you're looking for something that has to do with RAM, well, yeah, you are, but it's radiation of air-gapped memory bus for offense is kind of what we're looking for here. But
Yeah. The novel pieces are like, we're talking about RAM and we're saying it's not relatively new. Think about like on the on the silicone, the spaces in between the CPU and the RAM, right? Because if you tapped into that, if you had if you had a piece of wire into that, that's where the electrons are going back and forth, right? 1s and 0s, a couple of billion times a second.
yeah.
So that's what they're talking about. That's what's so novel about it. And then from that point of view, you can write. Like you can.
Okay. So and my head goes because my head comes around to this 2.4 gigahertz thing because there seems to be in the articles I read a relationship. This one said they successfully leaked from a 3.6 gigahertz, but something in my head, I don't know, maybe I'm wrong about this. It could be totally all wet. So 2.4 or 3.6, or it would seem like somebody would come up with means to, I mean, if you can do this with RAM, are there other ways to manipulate the CPU that's being explored?
Yeah, that's
Because
where the bus, when we're talking about,
yeah,
that's what you're talking about.
yeah,
And keep in mind each CPU, and obviously it's different manufacturers, mostly dominated by Intel, right, for
right,
CPUs. But there's AMD, and then each one has its architecture. It could be, 10 gen, right? But i7 and i5 are going to be different, right? And so it takes a different skill set, because you're right on top of like machine code, right? Which is, the oldest of, that's assembly, right?
right.
So you're deconstructing that, and you're going through the different layers of languages, right? Like, to give everybody an idea, like Python. Like if you were to Google what language should I learn for programming, right? Like most of the time it's Python. I argue Rust, but I digress. What I'm getting at, that is a fourth gen
Yeah,
language, right? And you can
right.
tell, because when you declare things, you can do it damn near native speech, where you get to machine code, literally you're like in ones and zeros, right? Think dot matrix printers, right? Like on or off, ones or zeros, ho or no ho, right? That's what you're looking at. And it's hard for a human to, it takes a different level of human in order to
Right.
do that, right?
Right.
Talking about like Grace Hopper kind of stuff back in the
Yeah.
day.
Grace Hopper. Oh man, that's a good note to put in there in the notes. Grace Hopper.
Yeah, man.
Cool. Um, anything else on that one before we hit the next one?
Uh no, no.
Cool. All right.